Hello everyone, welcome to my channel. If you are new to my channel, please subscribe to my YouTube channel, so you can join our tech family. If it is informative to you, please like our video, share it with your friends so they can get help with these video, and don't forget to press all notification bell icon so you get regular update and don't miss any single video.
You've used TCP many times, and probably not even known it. It's the feature-rich transport protocol, and the one that forms connections. It's time to see how these connections work. TCP is connection-oriented. If you're attempting an exam, you may hear the phrase connection establishment and termination. This means a device will start a connection to another device. They'll agree to form a connection and set up parameters like port and sequence numbers. Don't worry, we'll cover all of these soon. This is in contrast to UDP, which is connectionless. The application or operating system may do something to track the data going in and out, but as far as the network stack is concerned, the devices just start sending data. But don't worry about that for now. We're here for TCP. The connection establishment phase is called a three-way handshake. You'll see why it gets that name soon. To do this, it uses flags in the TCP header. Flags are bits that may be turned on or off. The device starting the conversation, that is, the client, sends a segment to the server. There is no payload in this segment, just headers. In the TCP header, the SYN flag is turned on. SYN is short for synchronize. This tells the server that we want to start a new connection and we need to agree on a few details. The first of these details are the source and destination ports that we want to use. As we've talked about before, the source port will be random and the destination will be a well-known number. The initial sequence number, or ISN, is also set. This helps both devices keep track of which order the segments should be processed in. This usually starts as a randomized value. I won't get into detail about this, but that's usually done for security. A window value is also set, but you can ignore that for now, as we'll cover that in detail in the next video. Now that the server has the first message, it can decide if it wants to be in this conversation. If it has an application listening on port 80, then it will indeed agree to this conversation. So, it will respond by sending an empty TCP segment of its own. In the TCP header, the source and destination ports will switch. The sequence number will go up by 1, as it's the next message in the conversation. And finally, the SYN and ACK flags are both set. ACK is short for acknowledge. By setting both of these flags, the server is saying, I have seen your request for a conversation and I agree to it. So that's two parts done. We've got one more to go. The client sends an empty TCP segment with the ACK field set, and the sequence number is incremented again. This is the client confirming that it received the server's last message. The SYN, SYNACK, and ACK messages are the three-way handshake that TCP uses to build a connection. At this point, the connection is established and data can be sent back and forth. Test yourself with these questions to see if this all makes sense. Have a think about them. Discuss them with colleagues or a study group and see how you go. If you want to see my answers, they're available on the website for Patreon supporters. After a while, it will eventually be time to close the connection. This could be because a process is complete, say a file transfer has finished. Or perhaps one device has taken too long and the other is sick of waiting. Or maybe something is wrong with the connection and it needs to be terminated. There are two ways this can be done, and either client or server can start the process. Firstly, we'll look at the graceful way to close a connection. One of the devices will send a TCP segment with both the FIN and ACK flags sent. FIN is short for finished. The other device replies with an ACK message. It will immediately follow up with a FIN ACK message of its own, which is acknowledged with another ACK message. So there's a lot going on just to close a connection. 4 messages, and they appear to be duplicates. So why are there 2 pairs of the same sets of messages? The first pair announces and acknowledges the intention to close the connection. The responder now needs to notify the application that the connection is closing. It might take a few seconds for the application to deal with this. The second pair of messages are sent only when the application is ready. Using 2 pairs of messages will give the application time to respond before the connection is fully closed. Now, the second way to close a connection. This is the non-graceful method. One device will need to close a connection and send a TCP segment with the RST flag. This means connection reset. And that's it. There's no graceful waiting for the application, there's no acknowledgements, the connection is just dropped. This type of closure would only happen if there's an error. It's common to see, for example, if a client tries to connect to a port that's not open. That is, there's no application using the port. So a reset message is sent before the 3-way handshake even completes. But that raises another interesting question. Why are there 2 ways to close a connection? Isn't one enough? Well, reset messages only happen if there's an error, so this happens with troubleshooting. So if we're trying to narrow down a network issue, one thing we could look for is reset messages. It's that time again. See if you understand what's going on by pondering these questions. Pause the video and give them some good thought.
We hope you enjoyed the video and found value in the content. We value your feedback. If you have any questions or suggestions, feel free to post them in the comments section or contact us directly via our social platforms. Thanks for watching.